a project from MOST and WRA, and we have preliminary result I'm going to show you today. So the title of the presentation is Reviewing and Characterizing Regional Land Subsidence in Yunlin County, Taiwan. I'm Gu Chenyu from National Taiwan Ocean University. The outline of this talk is, first I would like to give you a very short review of climate change, and then I will talk about the land subsidence problems within the world, especially in Taiwan. And then I will give you a introduction of mechanics of land subsidence. And then I will tell you how do we prepare the geospatial layers of our study area. And then I will give you a very short introduction of the analysis method, which is the principal component analysis. Finally, I will give you conclusions. As Professor Chen previous talk, he mentioned about the climate change. I don't want to talk about the climate change in details, but I would like to mention two important effects in Taiwan. That is the lead to global warming, change in precipitation pattern, especially in Taiwan, is a very big challenge right now to all of us, especially the people living in Taiwan. There are two problems and two challenges actually we are going to solve. The first one is the change of precipitation pattern, which means the dry season, due to the climate change, the dry season will more dry, and the wet season we will have more intense rainfall. So it will be a quite big challenge for the water resource management. Also, another big challenge is the sea level rising, especially in the west side of Taiwan. As you can see, this is the very, how can I say, this most serious drought of Taiwan in this year. I think it's WRA, the people, a friend in WRA, they should know this is the most serious drought in the past 60 years. For example, this picture demonstrates the Wusantou Reservoir, and here is Zhenwen Reservoir, and here is Deji Reservoir. I believe most of us used to visit this area before. As you can see, last year is supposed to be lake area, but this year, all these reservoirs, we can see there are many green grass, which means where is the water? There's no water anymore. This means we are strongly affected by the climate change. The dry season is more dry, and in this summer, we have encountered many flooding events in Taiwan. I think this all reflect the climate change, which is currently occurred in our living area. And because the dry season is more dry, many areas lacks of surface water. For example, we need to agriculture our crops. We have no water, no surface water. The only way we have to increase the use of groundwater. But the increase of use of the groundwater leads to many other disasters, such as flooding, such as land subsidence or groundwater salinity. So how to control the groundwater use become a crucial problem. And then we look at the land subsidence problem within the world and Taiwan. I don't want to talk about too much in other countries because the land subsidence is quite a popular disaster in other countries, such as in China, such as in Mexico, such as in Indonesia. And the first speaker talking about the South Asia country, we all encounter the land subsidence problem. Most of the problem is occurred by overuse of groundwater. Even in China, Mexico. In Taiwan, we also have this kind of problem. The left picture, as you can see, this is from WRA, Water Resource Agency. From geological point of view, in Taiwan, the soil area, which is original from alluvium fan, is in Taipei area, and this here is the Zhanghua, Yunlin, Jiayi area. We call it 浊水溪 alluvium fan, and the Tainan area and the Kaohsiung area. And in the east side, we have Yilan area. And the left side, land subsidence only occurred in the alluvium area. Most of the area in Taiwan, we are in mountainous area. In here, there actually no land subsidence problem. And the most important thing is the land subsidence problem in the 浊水溪 area is quite serious currently, because we have, in 2018, we have 6.66 centimeter per year. And Jiayi, we have 4.7 centimeter per year. And in Zhanghua, we have 3.4 centimeter per year. Especially in Yunlin area, we need to think about how to control the land subsidence to the accessible level. And if we look in detail of the 浊水溪 alluvium fan, the geological profile as demonstrated in this figure, we can see it in the mountain front area, okay? This is actually the recharge zone, which is very interesting for the recharge problem. And here, at the alluvium fan, the center of the alluvium fan, here we have very serious land subsidence, especially in Yunlin County. And in the coastal area, we have seawater intrusion and the fishery farmer. So there's sometimes they pump the seawater into the coastal area, cause the land salinity. From the regional groundwater system, the CGS have already identified the aquifer system in this area. But I would like to emphasize that is from the regional point of view. They say that there is 4 aquifer. Aquifer 1, aquifer 2, aquifer 3, aquifer 4. This is good from the regional point of view. But for land subsidence, actually, we have to look from different point of view. Especially, I would like to say, from geotechnical point of view, this kind of regional aquifer identification is not good enough for precise modeling. As just Professor Chen, he mentioned, the good input data, a precise input data, is the successful of groundwater modeling, as well as land subsidence modeling. This picture, thank you. This picture demonstrates the land subsidence trend within the past 20 years. As we can see, for different years, the land subsidence rate is different, which means the use of groundwater depends on the condition of surface water. If we have enough surface water, then we do not have to pump the groundwater, because once you pump the groundwater from the underground, you need to pay for what? Pay for the electricity. So if we have enough surface water, we don't have to pump the groundwater. So the Yunlin County actually is located in the central of 浊水溪 River alluvium fan. The lack of water resource, especially the surface water resource, leads to the overuse of groundwater and result in serious land subsidence in central Taiwan. From here we can see, right now actually in Tuku area, here we have most serious land subsidence rate. And this picture demonstrates the subsidence rate in Zhanghua County in the past 20 years. As we can see, in Zhanghua, the most serious area is around in the Dacheng County. But the good news is the overuse of groundwater result in land subsidence in Zhanghua County. The land subsidence rate of Zhanghua is mitigated in recent years. So we are currently also trying to find out the reason for the mitigation of land subsidence. Probably is the consolidation rate is going to a smooth line, which means it's finished consolidation. But we are trying to find out the evidence to prove that. The next slide, I would like to tell you about the mechanics of land subsidence. This is from geotechnical point of view. For the land subsidence, from geotechnical point of view, the aquifer is not important. But for water resource, especially for groundwater resource, aquifer is very important because aquifer is the soil layer which is water-bearing. It's the major water-bearing layer which is composed of coarse-grained soil. And the aquifer actually is our interesting soil layer because from geotechnical point of view, the consolidation actually is from the aquifer. And the aquifer is a bed of low permeable, fine-grained soil along an aquifer. Usually, the aquifer, if the aquifer is in here, the upper layer and lower layer will be aquifer. So it's most of the alluvial fan in Taiwan, from the drilling data we found, the aquifer system actually is a multi-layer aquifer system. One aquifer, one aquifer, one aquifer, one aquifer, more like a sandwich system. So the aquifer, from our point of view, geotechnical point of view, soil mechanics, is the compression of soil is the major layer for here. And the long term, but without groundwater use, it is fine, no land subsidence problem. If the groundwater overuse like this, as you can see, the depth of groundwater level actually is fluctuate, which means the seasoning, dry season for one hydrological year, we have dry season, we have wet season. The groundwater is supposed to be a sine curve, something like this. If the fluctuation of the groundwater level goes to a straight line, it is fine, no problem at all. The problem is once you overuse the groundwater, the fluctuation of the groundwater level will decrease. This may cause the dissipation of pore water pressure. The mechanics of this can be explained by this figure. This is a very famous experiment in soil mechanics. We call this instrument is an audiometer. It is very simple test, actually. If we put a fine grain such as clay or silt in here, the upper part is a permeable stone. The lower part also a permeable stone. First of all, we make it saturate. After the saturate, we put a load in here, a pressure in here, and then with time, we will find that the soil sample will have deformation. This is a vertical deformation. If we plot the result in here, here is the deformation, vertical axis, horizontal axis is time. We will find 3 stages of compression, 3 stages. The first stage is the